technologies. Let's see.
Are you guys still hiring?
Applied, no, we're in the process of hiring a couple developers that specialize in control theory stuff.
Okay. Well, if you want to plug it,
Do these kind of hookups. Do things for companies. One is predictive maintenance. Say you put a monitor on a motor, and you see the trend line of the motor all of a sudden starts to vibrate more, make more noise. You can get that data on the cloud. You're doing analysis on it continuously. It detects a change and it sends a text message to the maintenance people. They're aware immediately of a potential problem. They go to the
once I get you started,
device.
I'm going to start the camera, and then I'm going to go order the pizza.
We can develop the point solutions because it's all custom. It's a point solution. It's not generic peanut butter like most IoT devices. The cost, of the point solution is pretty big, for it. But I'm using off-the-shelf IoT and off-the-shelf type software. So a lot of it is just engineering work to get customized the system. But it adds some real value to companies because they're able to capture something that could impact hundreds of thousands of dollars. The ROI is there. So that's real. I'm using the slicing pie model. It's a model based by Mike Moyers for shared equity. This is an ideal way to do small startups where you're not going to, let's say, roll out a product across the nation. So venture capitalists are really interested in this kind of funding the company, although I am looking at investors for this. What that means is a person working under this model, you get paid when the company gets paid. So you build up your number of hours, you get paid at a risk value higher, let's say 2x what you normally get paid per hour for that kind of work. And then because it's delayed gratification, you're taking a risk. And it's a product wraps up, it gets delivered, and you get paid, funds go out, and your hours are paid out. So you get a big benefit later on. This is especially ideal for people who work on projects outside of, let's say, their normal job, or want to do different kind of work, or have other income that they live on. You do get equity in a business as the business becomes more valuable. It's a pretty neat model. It's very efficient. We have it all in interest in that. Looking for project team members right now, and I'm also looking for projects. So companies that you're working in that use this kind of project, and that's a double whammy. Because I also get sales.
Thanks, Glenn. Anybody else? All righty. I'd like to take a moment to thank Tech Shop for having us and allowing us to hold our events here. I would like to introduce Vicki, who's going to tell us a little bit about Tech Shop.
Thank you. First of all, I want to say thank you for coming and using the shop, and we really appreciate you being here. Some of you maybe have done a tour here, others maybe not, but I just wanted to give you a little quick rundown. We have about 18,000 square feet. There's only 8 tech shops in the nation. We are the only one in Texas, and we're a membership-based do-it-yourself / prototyping shop. So basically, you could build whatever you want here. We have an entire wood shop. We have a metal shop, machine shop, our electronics lab. So you can do, and we teach over 100 classes a month, basically how to use the tools. With membership-based means it's like a gym membership. You pay by the month, and you can come in and use the shop however often you want to. You can use it every day. We have some people that come once a week, once a month. Our hours are pretty broad. We're open from 9 to midnight the first half of the week, and from 6 a.m. till 2 a.m. on Thursday, Friday, and Saturday. So we are open for those of you who are working and yet don't want to use the facilities. Like I said, membership based. So we would love to give you a tour. For those of you who have never walked through the shop, when you're done, if you want a tour, just let us know up front. We'll walk you through. Yeah.
And Mark mentioned a new evening and weekend.
Oh, I was gonna say.
Thank you. Yeah.
Super awesome.
Yeah. So basically, we got a lot of feedback from people. Some people love coming in the day. Some are working in the day, and they didn't feel like they were getting quite the value out because they're trying to do both of these. So we are the only shop that's rolling this out, but we are rolling out what's called our nights and weekends. So for almost half the price, so a regular all access is $139 a month. Now for $79, you can do our nights and weekends, which means you come in from 5 till close during the week and open to close Saturday and Sunday. So we're trying to make it more affordable. So for those of you who think, well, you know, I just want to piddle around a little bit, but it doesn't have to be this. You can be, you know, in the machine shop, or you can be making a cutting board. Or doing
Considering
something
that a day pass is what, $50?
Day pass is $50 to come into the shop, which
For
so
an extra $30, you could have access to it the entire month
Yeah.
and still hold your 9 to 5.
Mhm.
So, one question is, so you have classes, I assume classes are in addition, right?
Yes.
You have to be a member to take classes.
No, you do not have to be a member.
For a day pass to take classes.
Well, so we've actually had a change. We don't offer day passes anymore.
Oh,
You can take a class. If you want to learn to weld, you can come take a class. If you want to learn to make a quilt, take a class or use, but we do offer a discount on the classes for anyone who's a member. So I would suggest joining, and you could save $10, $20, $30 for a class. And the classes are called SBU, Safety and Basic Use. So we're teaching basically just safety and then basic use of the equipment. As a member, if you come in, you get, once you're cleared on that 2-hour class, you have access to the tool. You just make a reservation and you can use it. But we used to let people come in, and now it's like, you know what? We're pretty unique. People need to be a member to use the facilities. So you can take a class, but you couldn't come back and use the equipment. But we have people wanting to learn things, and so yeah, I want to take a class with 3D printers or whatever. Yes.
I have a full 1-year repeating membership.
Mhm.
Are you offer a lower cost to that? If I'm limited to the weekends and the
We
evenings? Because
we
I'm
will-
ready to get a full-time job and that will cut into my time.
Yeah, we will do what's right. You let us know up front, and we will work for you. Yeah, so some people do have annual memberships, and if you want to switch it, just let me know. Okay? Well,
Very
thank
good.
you. Thanks for your time. Thanks
Thank you,
for being
Vicki.
here, and if you want a tour, please come and let us know.
Thank you, Tech Shop. Okay, another thing I want to mention is I brought some stuff here. I got a bin with a bunch of DuPont jumpers. I got some reed switches, a couple of breadboards, some LEDs, 10K resistors. So if you need anything, you can come out here and take a look and see if we have it. Does anyone have any questions? Okay, then without any further ado, I'm going to turn it over to Cameron. And if you give me 1 second.
okay.
I'll give you the
Cool. I'm Cameron Owens for those of you. Yep. Also, live streaming this as usual. Let me grab the link for those of you guys.
All right, try to stay behind the podium.
Okay.
3,
Oh,
1.
that's my cue. That's my cue. Cool. So I'm Cameron Owens. I know I haven't been around for a while. So there's without getting too many details, some stuff going on in my life. So I took a slight hiatus from the meetup, and now I'm back and everything. So now we're doing workshops and stuff as well on top of that. So, we've got adult beverages in there.
Yes, sir.
So we have some beverages if you're interested in adult beverage Cokes. Dave also is going to be ordering some pizza. So free food and free information. The world is adopting Linux at a faster rate than ever. I love it. Life is good. Free is in free beer and free is in freedom. So yeah, today we're going to be talking about the particle photon. Who here does not have a particle photon? Okay, well, if you don't have one, hopefully this will provide some information, maybe persuade you to get one. If not, you may come away and say, hey, it's a pretty cool platform, but I'm going to use a different platform. More power to you. So a little bit of my background, I'm a professional software developer for Applied Materials. So I get to play with robots on a daily basis. And then my previous jobs involved hardware software development for other robotics companies. So doing this kind of stuff is a whole lot of fun for me. So that's why I take time out of my life to come and share some information and hopefully empower you people. So when I die, the one thing that I want people to say of me, other than I was a horrible person, was that I empowered people. So all of the information that the Austin Internet of Things group puts together, as well as myself, is all free. So feel free to take this, do whatever you want with it, hack it, you know, end world hunger, and make the world a better place. So without further ado, let's get started talking with particle photon. How many of you guys are familiar with particle photon? Cool, awesome, perfect. Lots to be learned here. So in all of our previous workshops, one of the main things that we worked on was doing development using the Raspberry Pi. Raspberry Pi, hugely popular single board Linux computer. Probably shouldn't be showing that, so you see my ugly mug. But so the Raspberry Pi, it's a single board Linux computer ranging from $35 all the way down to $5. With that, it's a full stack Linux computer. So it has an operating system. It has all of those plug and play features that we traditionally think of for a computer, right? But a lot of times when people are looking at developing Internet of Things solutions, and I know that that phrase Internet of Things is very amorphous, like what is the Internet of Things? People in the industry don't even know. But a lot of times what that means are things like sensor networks, right? Is we want to put a sensor in everything, especially like what Glenn was talking about, is putting sensors on things and being able to do predictive maintenance. So a lot of emphasis on the Internet of Things is really deploying wireless sensor networks and then talk to the internet. Well, the problem with a full stack computer, cost. And we're going to break cost down into the sheer cost of it. So let's say $35 per computing module plus the sensor and all of that. That really becomes expensive. It's not very sustainable when you think about it. How do I get 1 billion sensors out there at $70 a sensor? That's ridiculous. And so it's not a real sustainable solution. Well, fortunately, there's another piece of hardware that electrical engineers know all about called microcontrollers. So the main difference between a computer and a microcontroller is that a microcontroller is the entire computer on a single chip. Now, an entire computer, I don't mean like a monitor or a keyboard and all of your graphics card and everything that you have from a traditional laptop. What I mean by computer is an arithmetic logic unit, or an ALU, plus your memory. So coming in forms of RAM, ROM. So it's a very, very basic system. So for those of you that are familiar with things like the Arduino is a classic microcontroller. What would be another classic microcontroller? The PIC-80s ESP8266. That's another. Now, one of the things that makes micros really nice is their cost. So on large scales, you can typically buy very powerful microcontrollers for, say, 75 cents a piece. And so if you're doing your own board layout, 75 cents versus like maybe $12 a chip, that's a huge cost savings and everything. I know it's hard to see on here, but here I have this is what's called a block diagram of a microcontroller. So maybe a little hard to see, but here you can see that there's a block for your CPU. So that's, your ALU, other functions. You have an oscillator, which is controlling the timer or the clock. You have some. Now, one of the things that really makes microcontrollers stand out is this component right here, this ADC. How many of you have taken electrical engineering courses or understand electrical engineering? So ADC, standing for analog digital converter. Where microcontrollers really shine is their ability to work in noisy environments. So whenever you start your car engine, and you have an alternator that's generating a lot of electricity, it's also generating a lot of electromagnetic noise, or EMF. With microcontrollers, they are designed to work in those environments, so they're much more fault tolerant. So they're designed to work in machine environments and things like that, so they don't pick up that noise as much. Whereas a traditional CPU, it is very delicately designed in order to reach those very, very fast clock speeds. And so it is much more susceptible to those things like noise. Also, with traditional CPUs, they're designed for one thing. So like whenever I talk to people about microcontrollers versus microprocessor, I say your microcontroller is like a 1989 Jeep, right? Take it anywhere. It may not be particularly fast, but it's got enough torque that if you tie it up to your house, it'll rip it off its foundation. Very generic type of device. Whereas a microprocessor, that's kind of like a Ferrari or a supercar, right? It's built for one thing that's going really fast on well-paved roads and looking really good. So with a microprocessor, it provides a whole lot of benefits that your microcontrollers don't. Well, the Particle Photon uses an ARM MX3 or an M3, an ARM M3 Cortex, or ARM. I forget how they want you to word that, but it's an M3 Cortex ARM CPU. So what that means is there's this company / organization called ARM. They designed this chip. They designed the physical layout of an ARM microcontroller, and then people license it and build their own chips. Well, the people at Particle, they designed with ARM. They created this microcontroller, and so it has built-in Wi-Fi. It has all of those nice features for an Internet of Things solution that you're looking for, minus all of the other CPU overhead. While still being a traditional microcontroller, so you can do analog input and convert those to digital signals. You can also take digital signals and simulate analog. So it's really great for controlling things, and then also being able to connect to a wireless network or Wi-Fi. Well, Wi-Fi is a subset of wireless networks. Not all wireless networks are Wi-Fi. But so you can use this, it'll connect to a Wi-Fi network and be able to stream to some other system, say like your Raspberry Pi, which will then be doing the heavier lifting of your processing. So the Particle Photon is just one of many solutions that are out there. So the other thing with microcontrollers is they're very power centered. They consume a lot less power. So you think of this as cost. One, there's the dollar amount. Two, there's also the cost from your power budget, or how much current and voltage do these things require. traditionally a CPU, or they're clocked in gigahertz, so they're consuming electricity like there's no tomorrow, whereas microcontrollers are designed to be very low power. So all of these ultra low power devices that you see out there are typically driven by microcontrollers. So like you hear about BLE, Bluetooth Low Energy. Well, that's being driven by a microcontroller, and then it connects to some other smarter device, which then has a traditional CPU. Anyway, I'm probably rambling a little bit. So the last thing that I wanted to talk about all of this in this guide, in this introduction of kind of introducing microcontrollers, is the other thing. Now, when I said cost, the Particle Photon sells for about $20 online, depending on where you get it. Now, you may be thinking, wow, that's crazy, $20 a microcontroller versus $35 for a Raspberry Pi that has USB and has Wi-Fi, all of those things built in. Well, it's also important to remember that this Particle Photon is considered a development board. So you're paying a premium for the breakout board, you're paying a premium for the supports, you're paying a premium for all of the other things. If you were to go out and design your own circuit board, when you go and talk to Particle, they're going to be telling you, yeah, pay $1 per chip, something. So the cost comes way down because then you're dealing in larger volumes. Whereas CPUs, the Raspberry Pi at $35 is almost kind of barely a loss, not just above a loss leader for them. And so they're very expensive to make. So enough rambling. So let's get into setting up your Particle Photon. So I see a couple Apple logos. For those of you with Apple logos on your machine, are you running Mac OS 10? Not pronounced X. So it's OS 10. Go up to the Apple in the top left corner, click About This Mac, and it'll be 10.0. something, something, something. So I was a Apple service manager at an Apple store, and it was like every time I heard somebody say, yeah, I've got Mac OS X, it was like baby kittens and baby seals were dying all over the world. It's 10. It came right after 9. 9.2 was probably the greatest operating system ever created outside of like Debian. Anyway, so for those of you that are on Mac OS 10, you will have a very easy process of setting this up. So Particle.io, the company that makes this, they're based out of San Francisco, where I guess everybody uses Macs because Cupertino's right there. So for those of you that have Macs, it'll be very easy for you. How many of you are running Windows? Okay, Windows will be the next easiest operating system to set this up with. You still have the availability and the option to use their desktop and everything. For those of us that are on Linux, we are treated as third-class citizens in this realm, and you basically are forced to set it up with a mobile device, unless you want to go and get the binaries and like precompile the ARM developer tools, and it's just like craziness. No, just pull out your smartphone and set.
And you said something about Broadcom libraries.
If you're developing on Linux, just use your Android or iOS phone. It'll be way easier. It's a scary rabbit hole that I tried to go down to, and I was like, an hour and a half later, I'm not doing this. Forget that. So I just set it on my phone. So let me share my screen real quick.
And do you know why it's not supported under an Android? Android ID?
It is sort of supported. It's a Java, or it's a basically, I think that because the Cisco company, they think that the world only, and this is my biggest gripe against the Particle Photon, is their support for other platforms outside of Apple products is, in my opinion, totally appalling. Much better platforms if you use them. But that said, the Particle is a pretty cool platform if you're in that ecosystem. I'm a hardcore person, like Linux or die type of thing, and Android. But that said, it's a good platform to develop on. So the first step that we're going to do, so here I talk about this, is sad face, no Linux option. You're pretty much hosed. So the first option that we're going to do is cover using your mobile device. Pretty straightforward. All you do is you go to the app store of your choosing. Because I don't have an iPhone, I couldn't provide screenshots for this. If somebody wants to buy me an iPhone, I will use it for that purpose. So anyway, so you go to your application store, so App Store, Google Play Store, whatever. It's going to be the same. And you're going to search for this app. If you search for Particle Photon, you'll see this app come up. It's the Particle. Now, here at Tech Shop, they do free Wi-Fi, so this will take a few minutes to set up. So I suggest using their Wi-Fi because data say that your data rates will apply, the application, but not your data. So you download the app, and if you just search Particle Photon, it should come up. It's just Particle. No, there are a couple other apps that float around on the iOS app that use Particle in their name. So I just recommend Photon. It uses their logo. So if you see this little compass-looking thing with compass meets a star, you're good to go. That's it. Okay, so the next step, we'll have to do this in phases because when you first set up your Particle Photon, what it does is it goes into hosting its own wireless network mode or a software-based access point. So for those of you that want to get them set up, what we'll need to do is we'll probably, whoever wants to go first, just say, hey, I'm setting mine first. And the reason that we want to do that is because if we all plug all of ours in and put it into setup mode, there will be a whole bunch of Particle Photons and we won't know whose is whose. Because it's not like broadcasting it. Well, it is broadcasting its MAC address, but you would have to like go into the firmware and figure out like, oh, what's my MAC address for this? So while that's downloaded, does anybody want to set theirs up first?
You need to set up Particle.
Yeah, so so while that was downloading and installing, we're going to hold off before we get into that of setting up our Particle Photons. I'm going first. For those of you guys with Linux computers, be aware that your computer for USB power, it will not, something about Linux trying to pull the ports to figure out what it is and communicate to it. You need an external power support or power supply. So what you'll do, oh, son of a monkey. I apologize, guys.
Is this a symbol for it?
Yep, that's it. Okay. So for those of you that are setting them up, when you plug it into power, you'll see some blinky lights. Everybody loves blinky lights. What you'll do is there's this button called Setup, which is right here. It's on the left-hand side. Well, depending on how you're looking at it. Let me scroll down. Kind of hard to see, but there's a little button next to the USB that you will press and hold.
3 seconds.
Yeah, 2 seconds or something. You basically hold it until the RGB LED in the center starts to flash. It'll flash on and off blue. Okay? So for those of you that already have the app and everything, you will probably see a Particle Photon if you're logged in. Okay, so now that's in setup mode. It's waiting for some configuration. If you go back to your device, you should have the application installed, and then it'll prompt you, hey, create an account. So one of the features, I guess you would say, of the Particle Photon is that all of your development is done online. So you have an account with Particle Photon or Particle.io, and they host all of your code. that you write and everything. It's completely free. It's just one of their features, I guess. It's kind of if you're, say, someplace and you're like, oh, I got this great idea, handle this control loop or something. You can always log in and access your code from any device. Depending on your perspectives of things, that's either a really cool thing or a thing that is an irritant. I'll let you guys decide. So if you don't have an account, you'll just provide them with your email and then put it in a password. Pretty simple, very straightforward. If you already do have an account, just tap on that option of, what does it say? Already have an account. Literal words, I looked at it and typed it up. So you'll get the application set up. And so let me launch mine. And for those of you guys that are following along, you will probably see my particle photon. So, oh, okay, cool. It's still nope. That's when it was at home. So in the bottom right-hand corner, you'll tap on that little plus, and then it'll give you this option to set up a photon, set up an electron, or set up a core. Yeah. I have extra USB cables. Is that what you need?
Well, I need something that hook my phone to this.
Oh,
I just have to.
Well, it has power.
oh, you need power?
Don't you plug the phone directly into this?
No, you plug it. Yeah, it does it over Wi-Fi. You just
Oh,
plug
it is for Wi-Fi?
Yeah.
You will need power, that's what
Okay, I get power then.
Okay, so I'm going to tap set up a photon, and it'll tell you to do the whole process that I just told you. Okay, so so there are 2 photons plugged in, but I know which one is mine. But you'll see a list populated of available devices. Yeah. So what it's doing right now is it's hosting its own wireless network. And you'll next to upload firmware parameters to join the Tech Shop Wi-Fi. And so your phone will send that information to it, and then it'll cause it to reboot and then join the Wi-Fi network here at Tech Shop. Where is my FHYL? So I'm going to tap on it, and then it'll say connecting to Photon. This is a picture of me doing it at home where my wireless network is called Cybertron. I love Transform. And so this process will take a little while. So just spinning there saying connecting to Photon.
And it's flashing blue, right? Your photon is flashing blue. Right?
Yep, my Photon is flashing blue right now. Gwen's the other one. Okay, cool. So the next process, it will then guide you through selecting a network that you want to then connect your photon to. So your photon is a bridge. And so what it's and passing it back. And to the red, but like purple for a second. Okay, so successfully complete. Okay, so what is the RGB LED in the center? That's when you know that you're good to go. Okay, so that's how you set it up. Pretty painless on a mobile device. So the guys at Particle.io think that you should set it up via a phone, which I guess is okay. The apps are pretty good and everything. Anybody have problems with that or anything, or don't have a mobile device?
So I discovered that the ID for the Photon is actually on the whole box.
Oh,
Otherwise, I wouldn't have known.
oh, okay. Yeah, I pulled the box and just threw it away in the
This
bread form.
has on the side here. it has,
Oh, the little hardware for it?
Yeah, hardware ID.
Oh, okay. Cool. So those of you that have a Photon, do you have the box for it? Okay, you're good. So for those of you like consumerist American, like rip it on the box, throw the box away.
That could have been easier.
Yeah, so it's pretty easy on a mobile device. Okay, so how many of you do not have a smartphone and want to cover how to set it up on your computer? Beautiful.
Well, you might cover it.
Yeah, so I basically took a lot of their directions from online and I was going to go through them and clean them up and make them much more literally exciting. Basically, what you do is you have to get Node.js from nodejs.org, installed Node.js. If you already have it installed, I'm excited for some stuff that I've got planned in the back of my head for the future. Node.js, cool language. It is JavaScript, I know. Sorry, Dave. JavaScript. It's like, have any of you guys ever seen like the explanation of like programming languages, and it's like C++, where it's like C with objects, and then it's like JavaScript, and it's like, what if we but then made everything more difficult? JavaScript. So basically, you go and you download Node.js and install it on your computer, and then you use Node.js to then you use their package manager to download the Particle client utility, and so that you go and get that, and then you initiate a direct connection like SSH or something to it over Node.js, I think. So you install the inline tools, and then some funky process of connecting to it and uploading credentials that way. A little bit convoluted. So that's why using a mobile device with Particle Photon, super easy. The process is exactly the same whether you're on Mac OS or Windows. Easy. So yada, yada, yada. Okay, cool.
Okay, when I try to sign into a new account, it says the email already exists. When I try to change my email, or change my password, it says it can't find the email.
Forgot password. There's a forgotten password.
Because I can't find the email.
So have you already created a Particle account?
Yes.
Okay. Just trying to retrieve the password now?
Right, I'm trying to reset the password, and then it says you can't find that address.
Probably what you may want to do is do this through your computer. Can I log out?
Or pick another email.
Yeah, pick an email. But if you go to build.particle.io, before you log in, there's a way to have your password and everything. Okay. Okay, so for those of you with Particle Photon, gone through the process of setting yours up, connecting it to the tubes. Okay, you're good. You're good.
I renamed mine.
You're good. You're good. Oh, you've already renamed it. Glenn's like 10 steps ahead of here. Okay. Let's do this. I'm going to leave. Okay. So now, once you have gotten everything up and running, step to do is to go to build.particle, which I've got here. Okay, and I'm sharing it. And let's go to Blinky. And that is incredibly hard to read. Be a bit fun. Thing to do is this is for the people that are here. We'll go to gedit, my second text editor of choice after Vim. Okay, this is much easier to use. Okay, so I'm going to show you guys what to do inside of gedit. It's a text editor. No need to get caught up on that. So I'll be showing the text. And the only that I will be doing that is because you can't read this, I'm assuming, right? Maybe?
No, and just, part of the features of Particle Photon.
It's a little bit better. So that you can see it much better on your local machines. Following along with all of our other workshops, you may start this code doesn't look like Python, and that's because it's not Python, it's C++. Well, ish. It's actually a language that is a derivative of C++ called wiring, which is basically C++ with a whole bunch of custom defined macros, which were made hugely popular by the Arduino people. Okay?
Don't they call it sketch?
They call your files sketches, but the underlying language is wiring. The short story is, if you know C++, you know this. It's the same thing, just some extra macros. So far into starting to do stuff with M. This is just C++ program. Okay, not a problem. Cool. Those of you that have a little boards, and I apologize, that we're going to do what I like to call the hello world of C++ programming for microcontrollers. The first thing that you ever do in like undergraduate engineering classes that involve microcontrollers. It's the quickest way to do something, to get results and feel great about it. So that said, here we're using some C++ language stuff. And the first thing that we'll talk about are comments. So comments in C++/C are going to be designated by 2 forward slashes, and which means that entire line is then a comment. But you may be asking, Cameron, you're talking crazy talk. This / asterisk with line, and it terminates with a asterisk /. This is what's called a multi-line comment. Please ignore the dotted line part. The multi-line comment part is really the / asterisk, and then terminates with the asterisk /. Okay. So here we've got another comment, variables and initialization. With C and C++, because it's very performance driven and memory driven, and we're not running a system which runs basically an interpreter, we don't get those beautiful things from Python called automatic typecasting and everything. C and C++, if I say I want to go get the squidgely blah blah thing, well, what's the squidgely blah blah thing? I have to tell you what it is. You know what it is, I guess. Bad example. But yeah, I have to define a term before anybody else understands it, right? That's what language is. So here in C++, we're using the word int. So if you came into the road to code stuff, you'd remember that Python has this, typecasting an int, which stands for integer. And then we provided this variable name called blue LED, and then we set it equal to this D7 variable. Basically, what we're doing is we're telling the code that every time I reference LED, I want you to use this value of int D7. So it's the value is D7, the type is it's an integer, and its name is blue LED. So on your particle photon, you may notice that in the center, there is RGB LED. But then if you go to pin D7, which has a little blue line on it, a blue LED in line or in series with the pin. You also turn on an LED. So it has a built LED that we can turn on and off. And that's what I'm doing right now. So I'm just assigning pin D7 to this variable name. And I'll show you why later. The next thing is I declare another variable called time delay, and it's of type integer, and it's a value of 200. And this is going to be a time delay that we'll use to turn the LED on and off every 200 milliseconds. Okay. Now we start jumping into our functions. So we've declared our variables with the Arduino and Photon and basically everything that's Arduino-esque. There are two primary functions that you have to have in your firmware. I know Particle calls them applications firmware. So the first function that you have to have is this void setup. So this is a function that is called every time your microcontroller first turns on. So when it's first booting, this is like, it's going to call this function. It's going to ask itself, how am I supposed to operate? What am I, what are my initialization procedures? And so there's this void setup. And the only thing that we're going to plug in there is we're going to use this predefined macro function called pin mode. That is a capital M. C++ is very case sensitive. Programming languages are. They're very literal, like my wife. I wish. No, my wife's not very literal. Yeah, this is recorded. It's already on the interweb. I'm host. I love you, Rebecca Owens. Okay, so we're using pin mode, so that's a lowercase p, capital M. What this does is this tells the compiler to define this blue LED variable as an output. So going backwards, we're saying pin D7, that's going to be an output to our microcontroller. Okay, pretty basic, pretty simple. The next function that you absolutely have to have, let me change this so you guys in the back can see it better, is a void loop. For those of you that have done a lot of Java or C++ programming, this is your void function. So they call it void loop so that teaching kids how to program, they understand that this function is always looping, always cycling after it's been set up. So what I do is I say void loop, call a function called Blinky, and I'm going to pass it the arguments of the blue LED and delay. So I've introduced a new complexity that beginner C++ don't really talk about until later on, is I've defined another function. So I say void blink. What this means is that this is a function called Blinky of return type void or nothing. It doesn't return anything, so don't expect anything out of it. It has the input of an integer of the LED pin and then another integer called wait time. Okay, so we've added our own custom functions. So we're learning how to write our own functions and subroutines. This is really handy when your code starts to get really big, and you want to put these functions other places. So what we do is then we call this function called digital write, capital W. So things are camel case. So it's digital write. We pass it the input argument of our LED pin, and we tell it to go high. So anybody not familiar with Boolean logic? Cool. So high equals 1 or on, low equals 0 or false or off. Okay, so what we do is we tell the microcontroller to write this high value, we tell it to turn it on, which means that we're passing current through the LED to and then back to ground. So we turn the LED on. And then we tell it to wait this variable wait time, which was, what's the value for wait time? Yep, 200 millis. So time by default on the microcontroller is in milliseconds. So if you want or a wait time or time delay of 1 second, you would do 1,000 milliseconds. To be half a second, you would do 500 milliseconds. Points. Okay. Asking to reset Tech Shop Wi-Fi or the?
Correct. Still set my own Wi-Fi.
Put it into setup. Hold the little setup button for like 10 seconds. Starts flashing. It's okay. So jumping back to the code, so we wait 200 milliseconds, and then we do digital write the LED pin to go low or turn it off. So we cut the power to it, and then we wait another period of time, but then I also multiply it by 5. Blinks and then goes off, and then blinks and then goes off, blinks and then goes off. So it's asymmetric, right? It's not just doing this, it's like on off, on off. So you can always do math on your variables by plus, minus, multiplication, etc. Okay. Pretty straightforward. So that is the sketch or the code that I have on it this very moment. So see how it like turns on and then it's off for longer than it is on, right? Ooh, ah. I have to wear my heels and my red dress. Yeah. Welcome, you're on the Price is Right. Okay. Cool. So, anybody want to quickly get into their particle.io and then load it? Okay, I'm going to grab some real quick. But before I get water, I have to explain how to use this interesting IDE. So the first time that you come here to .particle.io and you've logged in and everything, the first step is create a new app. Now there is already Blink and LED, and if you copy and paste this, you won't learn how to code. The only way to learn to code is actually to physically write it out and enforce you to write it. So if you want to become a better developer, I recommend typing it out yourself. And if you want to copy and paste, you can do that. No shame. But what we'll do is we will create a new app. And the first thing that you do is give it some sort of title. That's through the website, so it's build.particle.io. So this is what you'll do on your computer. You can do from your mobile device, but it'd be challenging with the little keyboard. Okay. So we're going to call it Blink Lights, and then we will save it. So this is one thing that can get you into a lot of trouble through this web IDE is to not save. I did this like 5 times. I was just like, ugh. Okay, so what we're going to do is we're going to save it.
Do you want to list your device and make sure you've got your device connected?
Yeah, great question. Great thing. We'll try it the first, and then we'll make sure that we connect since we're out. Are you connected to your Photon via USB from your computer? That was the only issue that I had with the Android app. Uh-huh. You want to use phone? Uh-huh. Okay. Are you running a root version of Android? Okay. Oh, something that I experienced while setting up my Chromecast last night. Do you have automatic switching turned on? So it'll do that smart switch, right? If your local wireless network speed is slower than your 4G connection, it'll switch to 4G. You might turn that off. So it's under your Wi-Fi settings. Okay, so jumping back, what we'll do is I'll put this code up here. And so what you'll want to do is write something similar or exactly the same here to this. So since I already wrote this, I'm just going to copy and paste it. Okay. So for those of you that want to write this out, I'll leave it up here. Or do you want to write it out?
You're starting from one of the other sketches, or you're just drawing your own program?
I wrote my own.
Is that available anywhere else?
I'll put it in that doc.
Yeah.
So this is one kind of thing that I have for frustration. There's not an easy way to share your code. Okay.
You could do a URL somewhere else.
Uh-huh. I want. I looked at. Oh, that's their docs.
Can you message it on Slack? Just copy it and send it out on Slack.
No, because it's linked to my account. So I poked around looking for like a GitHub integration.
Or Dropbox. There's not a thing where it'll add.
No, you only have like a couple buttons. You have your flash, your verify, your save, and then there's a whole bunch of dead space. Then the code itself, libraries, docs, devices, dashboard, and then settings. So you can download the binaries. Yeah, so you can do that. Doesn't really help people. So I copied and pasted it into the Particle Photon document, which already has a link posted in our Slack channel called Getting Started with Particle Photon. So the beauties of Google Docs is everybody gets access to it immediately, right? Like group collaboration. So you should see that at the very bottom. And it starts with this comment, and then I called it Blinky. And then I go through the whole code. So let's come back here to build. So I apologize, it's hard to see, but what I did is I just copied and pasted all of that. Now, before I want to try and send this, with really large code bases, you want to run a verify process. This is like Visual Studio and IntelliSense, right? As you're writing code, it's checking it for you to make sure there are not any grammatical errors or typecasting errors, etc. So what we'll do is we'll just click verify, And what it'll do is it'll basically pre-compile code for us, check to make sure that no logical inconsistency.
Wow, I mean, it's not just this that's combined, it's all the other.
Yeah, exactly, because it's doing it over the air. So there's a lot of additional code that's happening. Okay, so the thing that Fred talked about is your device is connected. So here on builds.io, there's this devices button. It looks like crosshairs, a target. Or what we'll do is we'll click on this, and we will select this device. Mine's called Turkey Trojan. Yeah, I'm going to call it Starscream. Okay. Cool. So
It's supposed to be green, right? Is it showing green on that? Or I guess it's flash.
yeah, it's showing blue. So this is device. This is a device that's registered to count. That's part of the process of when you set it up through your mobile device. And then the very last step is to click this flash. What that means is it'll send the firmware over there to your device, and then you'll start seeing some like flashing LEDs, and then you should see a blinky LED on this D7 that you programmed.
And your status line on the very last line kind of tells you what's flashing.
Yeah, exactly. So Fred was talking about here at the bottom, you will see it saying it's flashing, going through the process. If it's successful, then it'll go back, it'll say success, and then return back to ready. So I'm gonna go grab some water. So I'll be back in a second, and then I'll help you out, Mark.
Did you include the concepts? Yeah, then you need to go to the Arduino library. Oh, no, the concept. You have to do the library and type the concept file, and then you'll get then concept. Yeah, now click it into.
There's another library that comes up as data for.
Now, you want this. Now.
Okay, we'll see if this works. Thanks, Fred.
His instructions are kind of vague.
Yeah.
I mean, he didn't say that, but I mean, as far as.
I was gonna try that next, but it was confusing because. It comes up and then there's another one. So we'll see. Multiple hubs. That was gonna be my next step because it does say that it was in the vague order. Because the AF2 stuff came up. That seemed like they'd be more fun.
Yes, sir. I have seen listings of it. They don't really, did you get your full architect?
No, well, I think the mode where it's now, it's still listed my Wi-Fi at home. It's listed on the Wi-Fi here. It doesn't have a password as such.
Yeah. Well, yeah, I don't know, man. But, yeah, like that is just.
It still says it's offline here. It's having connection.
It's actually pretty convenient. What I'm thinking about here is like so Wi-Fi, so it's like
If it's offline, you can't go all further, you have, I think I have.
Yeah.
Yeah, we are. Which is strange, because like, a lot of, IoT stuff, most, it's like, it has to be like this. You can't
this.
it's off.
I forgot my Wi-Fi. That's so maybe get a look on this and then figure out why it's not reaching this.
Yeah.
And they're coming in with theirs.
Yeah, that's the green, that's Bluetooth, then for 3 seconds.
So it's the ESP chip.
Yeah, when I was really looking a while ago, there's also the ESP32, which will have the DLE and Wi-Fi. And so you can toggle between the radios, and you can have DLE mode, Wi-Fi, you have power. And so you can just kind of sitting there, and have really close data transfers and everything. Yeah, the switch to Wi-Fi is convenient. So that's a ESP32. Yeah, so some hardware developers have okay.
So it's supposed to be quite smaller.
Yeah, a little bit smaller, power sensitive.
And that's how we see the road is use stuff.
That's actually my preferred.
So
You can do some. Wait, load on this side, but it's not on that side.
I cheated, anyway, I really
Well, it's not, yeah.
So, because the little interpreter. Well, then they need things. If you start going to the firmware, you have to get rid of that and just do it all in the same. That's pretty awesome. That's quite cool.
I didn't have to download all these libraries.
Yeah. So truth be told, I'm an ESP82 fan, just because the community behind it is like they're doing crazy stuff with it, and you can get them. You can get Node MCUs for like $3. Yeah. Now the trade-offs though is they're notoriously buggier than things like the Photon. So it's like, do I want to deal with it? If you're a professional developer, somebody in that world, you're like, oh yeah, no problem, I can handle this. If you're learning to code, the Photon is just, it's super friendly. No, but I have seen it. Yeah, there are too many things, too many things.
So it's not listed, yeah, you have to go. Just right here. But it's red, yeah. You have to go back and discover.
Oh, IF config. So I sit in a cubicle farm for my professional job. I think a couple of us probably do here. No shame sitting in cubicle farms. It's better than working out in the hot sun. But the sad thing that made me sad and us is all of our software development is done in Windows. And so I feel that like just now I was like, oh, what's my IP address? IP config. Oh no, silly Cameron, I'm on Linux now.
Yeah, factor is all. Factor.
Factor, what's that?
One of it, and figure out stacks for your operating system. So if you factor IP address, consider like that, or if you just type factor,
Ah.
you just throw in these, then you have to install factor.
FACTOR? We'll play with this. Mm-hmm. Okay. Cool. Yeah, I will play with that. I love learning about new tools. But every day I come home, and I pull out my personal laptop, I'm like, ooh, Linux, I love you. So easy to do things. Don't get me wrong, I've learned to love certain things about Visual Studio. Windows is still kind of like I have to work with you. You're not that bad, but when it comes to distributed systems, Linux is just, it's heavenly for me, my perspective. Coworker do use that quite a bit because we're both kind of Linux Python-y type of people, and we're like, oh, I want to do this command, and I can't, so Sigwin to emulate. Cool. Anybody having questions? Did everybody get the blinky going?
Well, that blinking would why. I'm still trying to connect to.
Oh, okay. Okay, so let's take a look at your device.
I actually want to set the Wi-Fi up here on the X shop line.
Yeah, so what you want to do is we'll come here and you install the app. Ooh, you got any good Pokemon? Okay. Yeah.
I've got two before. Pretty sure this is a marker offline.
Yeah, here we go.
Yeah, kids that do set up my Wi-Fi.
Yeah, so,
That's the unit.
okay, so we're gonna, well, we have to put it back in access mode. We'll reset it. Is that okay?
Yeah.
Okay, so we're gonna come here.
We said this one, not this one.
We're gonna hold that.
Which one? This one?
Yeah. Okay. So we're gonna tap on the plus, come here to photon. Okay, we're ready. Your Wi-Fi is on, right? Okay.
Maybe just, that's what I was asking, is it need to be on X shop or is it one track this directly? Because I see two photons out there, the ones that we can have revenue.
get the iOS devices, people get counter okay, so then we're going to go to our settings, go to wide, and you should see a photon that works. You remember which this FW?
This guy does.
Oh, Dave.
I assume that, yeah, it's still about.
Yeah. Okay. So let's refresh. Right. Hold it down.
Oh, refresh.
Yeah. See.
Oh, so do you want transit?
It's a high. We watched.
Possible that there's works that on devices it doesn't have a problem listing more than 5, right?
Should be with it.
Well, let's try this guy. This other one.
I know that's a power cut, but you don't think very much use.
I'm going back to it.
You think it is power? That should just be power, because that kind of sounds like that problem you said.
Linux.
Dedicated serial. Maybe there's a serial.
Come over here. Let's.
Maybe it may be more than a power outage.
Okay. You mind if I see your phone mark? Yeah. How do you like the iPhone 6?
Yeah, but if you know what you're doing.
Eventually, because my side is I can read websites, and I couldn't do that.
Is,
Yeah.
Just didn't know that. Switch.
I think you start, yeah, but you said that's not.
That is their which interfaces with their dashboard, I believe.
Doesn't do a whole lot for you, so.
It's more, probably more on the video.
Yeah.
So how do I get the program?
Those things for that project, you.
Download it. I'm going to show you.
If we were there,
Particle build over here. There's the code. And then
There's a lightning bolt
on the top. See here. Light bulb, yeah, what is it? There's a check mark. Piles of things. This is
We took your vote.
Oh, okay.
Very good.
Yeah, I don't know why it's not showing up.
Yes. Well,
Yeah.
right. And if you want the next step. He showed it, I think it was more of it.
So on iOS, this is the, why I said in their sandbox, you have to do it through the system.
But then
Yeah.
Chris like that showed the. Well, he showed where it was changing.
Quite possibly. Do we want to show it? So the app tells you to go to your Wi-Fi settings and then you should see Photon dash. So I guess applications on iOS.
And then song.
Oh, that's what you're saying. So,
You should see on your list.
it was there. So
That's what that is.
And you have to actually.
I saw the variables change. Events, it was more kind of like events.
Right. Is that it? The saturated number. Oh.
because I saw it in that list on this phone.
It's weird.
Yeah. Yeah. Outside.
Well, is there a way to just do a total clear and do it?
Oh, was slow flashing way to set up.
Actually, close it.
Join that channel. No, he didn't kind of do that. And he said, oh, you should really do this in the second function.
Not particularly more.
I've had several others in there. They seem to the same.
No,
Yeah.
no, he didn't work.
And it's also the first, it's Rev 1, so it might have a different setup process.
And that's what you did, right? So you've got.
It's using the original TI chip. It's going to use Broadcom. Yeah, you might want to go through their command line tools that are built right on there. Go to- go to- Yeah, I plugged it into the power USB. Power port.
Well, mine is 8.4. Yeah, you don't have it.
They show three devices. One of them is the cellular, one of them is the photon. The other is something else. Is that between 1 and 2?
Okay. I only have about 15 more minutes of playtime, and then my wife says I have to come home. So we're in the process of showing our rental. So like, we can't be home with our dogs because then like people would come into the house and be like, oh, there's this crazy dog jumping all over me, or like the dog runs out the street. Anyway, she needs me to help with having the dogs outside of the house. So other than Mark, who will be helping later on, is anybody else having trouble flashing Blinky? Everybody get that set up and everything?
Well, and you didn't talk about Tinker at all either.
I didn't. I'll probably save that for a later date. Since I haven't fully played with it, I've only played with like the MQTT stuff. So Tinker's their dashboard integration, right?
Tinker is part of their app.
Oh, yeah, where you can manually turn pins on and off and everything. Yeah, so play with their application, kind of get familiar. I'm not particularly an expert on the Photon, so I would just write code to get those things to do it. But you can manually turn pins on and off from your mobile device. That's one of the benefits of using Photon. You get a lot of really great support. Okay, so the next thing that we're going to do is play with MQTT. Is anybody here not familiar with MQTT? Okay, not a problem. I'll give a quick overview of MQTT. So have you ever done TCP or message protocol type of stuff? MQTT is just another protocol. It was designed for low power, low consistent networks, so very noise tolerant. You can define your own quality of service. It's not the end of the world if your device leaves the MQTT network and then connects like 20 minutes later, or things like that. So there's a lot of like consistency and quality of service stuff built into it. And error handling. It's also very lightweight, so it's designed for sending things like sensor values. So the people that designed MQTT actually designed it for using satellite radio networks, so very low bandwidth, very expensive to run, so they didn't want like large amounts of data sent over those for sensors that were monitoring oil pipelines. So you're just getting like a pressure or something and then sending it. So up until this point, we've done some MQTT stuff with Raspberry Pis. So for those of you that are more familiar with it, you'll remember that you need a MQTT client and server and message broker. So those are the three major components. With systems that have full-fledged operating systems, such as your Raspberry Pi, your desktop, or say a web server, that device can serve both functions. It can be a server and the message broker, right? Typically that's how it's done. With things that are microcontrollers, they can't, actually you can, it's just a lot of hackery to get it to run as the message broker. Typically you want things like full-fledged operating systems being the broker. Anyway, we're going to talk about how to use MQTT on the Particle Photon. This is for, like, let's say you want to put one of these above your door with a magnetic reed switch and have it send you an email every time somebody goes into your door or something. MQTT is a way that you could do that. So with the Particle Photon and MQTT, it is very, very easy to do that. What we're going to do is we're going to come here to my code files. we're going to take a look at this MQTT exam. Nope. Oh, nope. Save it. I'm thoroughly disappointed in myself if I did not save it. This MQTT test. Yes, it is. Okay, let's copy this. Okay, so this is a piece of code that I sort of modified from somebody else's, in which we'll kind of do a very rudimentary discussion of how to integrate MQTT on here. Because MQTT is such a widely popular message protocol for microcontrollers and IoT things, all you have to do to add that library to your Particle Photon is this one line. It's pound include MQTT/MQTT.h. And then you have all of MQTT at your fingertips for your microcontroller. Okay? It gets it from the web compiler. So again, kind of coming back to a lot of the things that you get when you pay $20 for a Particle Photon versus like a $4 Node MCU, is you're getting a lot of this amazing online code management stuff that does this for you in the background. So you don't have to download MQTT to your computer or download the libraries for it or anything. It will manage it for you.
It used to, you had to go into Particle Build,
Mhm.
the libraries that way.
Yeah, MQTT. Yeah, so MQTT is such a widely used library that it's already part of particle.build.
And you don't have to use Particle Build to bid it. You just have to use the phrase in your
Correct.
source.
Yeah, so this is, so like any other C/C++ programming, to include a library and a header file, you use the pound directive and then the name of the library. What was that?
Oh, I'm sorry.
Oh, okay. Okay, so then the next part is we go through the process just like our previous code. So the first thing is we are going to create a byte stream. Now, without getting too much into the technicalities, think of this as just an array of characters. So we're calling it this little server. And so what we're going to do with all of these X's is we're going to put in the IP address of MQT server. So if you guys use my laptop for the time being, here's my IP address. And I'll get an MQTT listener running. LS.
Or do we want to use austin.iot.com?
You could also use that one. I am not entirely aware of all of the details due to my hiatus, but I know that David Fowler has set up an MQTT server for us. Yes.
I actually set that up.
Oh, that was all the Docker stuff, huh?
It's, well, the website is on Docker. The MQTT server is available at austinIoT.com on port 1883, and there's also WebSocket support on port 8883. You will have to set up a subscriber to see it.
Mm-hmm. Yeah, so whatever gets published to it, it'll just, as long as it's publishing to the right topic. So let me, so CD, was that workshop 3? That was.
You're setting up the particle as the server.
It is a, yeah, it's a server.
That'll be broadcasting something and you're basically subscribing to.
Mm-hmm. Yeah. So let's let's. Let me change this guy. We're going to create a topic called /hello world. Okay. Oh,
Pizza's here, feel free to help yourself.
hey, I smell it. Okay, so yeah, so I'm gonna write the topic that my subscriber will be listening to. Okay, so the generic topic is this hello world topic that it will be subscribing to and listening to.
Capital W, capital W,
All lowercase.
all lowercase.
All lowercase. My IP address, thank you for that, is 10.11.17.140.
Will that still be available after the presentation?
No.
No, it'll change, thanks to DNS. Conda, or source, Conda activate, or activate source. Okay. Oh. Um, um, the heck? Uh, um, active Conda and list. Sudo activate IoT. Oh. What the heck? Oh, source activate. That's what happens when you're working on multiple environments. Python MQTT subscriber. Okay, cool. So I've got this MQTT driver running. So it's subscribed to Hello World. Up. So I'm going to do, I'll plug in this IP for my server, or for my laptop, which is 10.11.17.104, 140. Okay, flash this guy.
got that code in the Blue document?
Part of it.
Part of it, I will. 18. Too many decimal points in number. Do I have to pass that as a string? I do have to pass that as a string. Okay. Let's just. What the heck? Oh. Line 20. Oh, didn't terminate that. Terminate that. Live coding at its finest. Error callback not used. Let's comment out the callback. It always bothered me when a compiler is like, hey, you defined this function, but you don't use it. Cool. Like, what is it? 27? Yeah, no matching function for call to MQTT, MQTT 22. Here, we'll add this callback function. It's not going to do anything because I'm not publishing. Callback was not. What's the issue? It's not declared in. Oh. Derp to derp to derp. There we go. Okay. I'll tell you what was going wrong. For those of you that are C++ and Java programmers, you'll probably laugh at me. I prototyped after I called it, so it hadn't declared. If everything's working, notes. It's like me trying to use a word before it was defined, and then later defining it later. Winning. Okay. How often does it wait for? Every second it should be publishing a message. Pub topic. Why isn't it publishing? Joining if client is connected. Client.loop. Terminating semicolon. It'll be the death of me. I don't know why not psych. Oh, I need to take this and put it here. Okay. I need to take a look at this and why it's not looping. But let's take a look at the code real quick. I apologize for coding on the fly. I changed this to a character string. Server. Enter. Okay. So the thing that we do is include, just like we didn't do in Blinky. We didn't include any libraries, but so we include that. Then I declare a couple of variables. One is server, which is a character string. The other is our publish topic, which is hello world. I changed this to be all lowercase. The next is this subtopic. So you could have your sensor all subscribed to something. So this would be how you would push messages back to the device. Say you want it to do a certain function if the weather is something and your Raspberry Pi tells the particle photon it's 89 degrees. So it sends the message 89 degrees, and depending on internal logic, you could then do something. So you can have the particle photon subscribed to stuff, and this would be a character stuff. I don't know. Let me move this back up here because that's how it can work, right? Okay. Oh. And then that will not be a comment here. Okay. So then the next that I wanted to kind of talk about is what's called prototyping. So if any of you have done C and C++ or JavaScript programming, this may be a term that you're familiar with. What this is it's a good way of keeping track of your functions and the structure of them. This is kind of a segue into developing your own header files later. What we do is we declare the function, but we have yet to define the function. What this does in the compiler in the background is this will assign a namespace to the function called callback, but it doesn't have a definition. You're just aware that this function exists, and it takes these arguments. Okay, so we haven't defined anything. This is what's called prototyping.
Yeah, it tells the compiler that there will be a definition for that.
Mm-hmm. Yeah.
So, would you have to do that if you just make a function right here?
You wouldn't. It's just a good practice. So this was what was kind of done before header files and kind of when everything was one giant file. This is the way they did it before. Now they break things into headers and libraries and going down the chain. Mm-hmm. Okay. So then the next thing is then we create we instantiate a client that's of class or type MQTT, and we pass it in these arguments. First of which is the server that we want it to talk to, or where the message broker is. So I used server incorrectly. What I really mean is where the message broker is. Okay. The next is going to be the port on which it is talking to. So the default port for MQTT/mosquito stuff is 1883, and then the last argument is this callback. And so this is a function that will be called whenever it receives messages. So it's like, oh, you sent me a message, this is what I'm supposed to do. Okay? So then the next thing is we define this function called callback. This was something that was floating from somebody else, from another example. What it is it takes in, so it takes a variable of the topic. This is the topic that it subscribes to. Then it has a byte string for its payload, so whatever the message is that you send to it, and then this unassigned integer of some length, which is then here. They do some funky stuff. They add a null terminator at the end. They have a pointer. Yada yada. You can send a message and you can change the color of the RGB LED. Not too fancy. The next one is this void setup function. So coming back to Arduino, Photon, everything under that umbrella, you need at least two functions, your void setup and your void loop. Okay, and so what we do is we tell it to, so it connects under this device name, SkyScream Photon. So it announces to the message broker, this is my device ID. I'm SkyScream Particle Photon. And then it will then also publish and subscribe. So these are the initial messages that we're getting here. So here, each time it joins the system, it said, I'm joining the system. This was a message received on this topic. Okay? And then we also tell it to subscribe to our subscription topic. And then the very last thing is this void loop. Come on. So void loop. So if it's connected, it's supposed to publish, and then it's supposed to delay for a second, but it's not publishing for some reason. Let me pull up a previous sketch that I did for a node MCU, so I can try and figure out what did I miss. Sketchbook. So this is for my internet-controlled flower pot. Oh, okay. So let's just get rid of this section. Actually, let's just get it out of that comment. We're not doing... And I don't have to call the client.loop. Okay. Yeah. Why is it not publishing? Got my pub topic. Okay.
It's a tough IDE.
Huh?
It's a difficult IDE to work with.
Yeah. But it's supposed to just take this and just publish. I want no. because it published this message, no problem. Okay, I'll have to take a look at this. Figure out what's going on.
But you probably publish to the Google Doc.
Here, let's take this little, if it's not connected, and tell it to reconnect. Maybe it disconnects after it first. Right. Oh. Hey, honey. Hey, not. Sorry. I know we need to be back at the house in like 15. Okay. Sorry. Bye. Yeah. Just this. No, I don't have this fun connect. Client.connect. Yeah, but it, okay. Nope. Aha, there we go. It was disconnecting. Cool.
All right, so what's different? What's the difference?
And then I got to wrap up and leave, or else I'll be in big trouble. Let's come down here. Let's paste it in here. What I changed is this function. So I inverted the logic, and I said if client is not, so client dot is connected. So this is a Boolean check to make sure it's connected. I said if it's not connected again. So what must have been happening is it was disconnecting after it connected initially. And then I told it to publish to our topic that I'm still here, and then to wait a second, and then to loop back. So if we come here, it's now saying every second I'm still here.
Okay, so when you say it disconnected after setup loop?
Yeah.
Setup function of it?
Yeah. So I was never doing that initial publish. So I put that in the document. So yeah, so your guys'